Welcome to today's deep dive. We're going to be exploring floating solar farms.
Oh, wow.
Yeah, solar panels on water. It's way more interesting than it sounds, trust me.
I bet.
We're diving into a document by DNV.
Okay.
They're kind of like the authority on setting standards in all sorts of industry.
Yeah, they're a leading certification and classification body for sure.
Right, exactly. The document's called DNVGL RP0584.
Hmm.
And it's their recommended practice for, get this, floating photovoltaic systems, FPV systems.
FPV systems, that's what we'll call it.
Exactly, FPV systems. And get this, over 20 major companies in the renewable energy sector helped put this document together.
Wow.
We're talking big names like Equinor, Total.
Yeah, I know those.
So we're dealing with some serious industry knowledge here.
Absolutely, yeah. And this document, it really gets into the nitty-gritty of what it takes to design and build these systems, covering everything from, like, the floats themselves to the environmental impact.
So before we get too far, can you give us a quick rundown of what exactly an FPV system is? I mean, I get the solar panels part, but what else is involved?
Well, the document defines it as the ensemble of components, including PV modules, supporting structure, station keeping, balance of system, up to the point of connection. It's basically all the parts that make the system work on the water.
Ensemble of components sounds fancy.
Right.
But I'm guessing putting solar panels on water, it comes with some unique challenges, right?
You think?
Like, wouldn't they just float away?
Exactly. You need a way to, keep those panels secure, and that's where the supporting structure and the station keeping come in.
Okay.
So the supporting structure, that refers to the floats themselves.
Okay.
And station keeping refers to the mooring system that anchors the whole thing in place. And then you have the balance of system, which includes all the electrical components, connecting the panels, and getting the electricity where it needs to go.
So it's like a floating city of solar panels.
Yeah.
With its own infrastructure.
That's a great analogy.
And like any city, it needs to be designed to withstand the elements, especially when you're talking about an environment as, well, unpredictable as water.
Oh, absolutely, yeah.
Yeah.
Wind, waves, currents, ice, you name it.
Wow.
These systems have to be built to handle it all.
That's wild.
Yeah, and the document, it goes into detail about how engineers design for those challenges.
Okay, let's break this down a bit.
Sure.
Let's start with wind.
Okay.
How do they account for something as unpredictable as wind?
Well, it's not just about average wind speed.
Right.
They have to consider gusts, sudden direction changes,
Oh, wow.
even turbulence.
Yeah.
They actually create like these hypothetical scenarios called design load cases
Okay.
to test the system's resilience against like the worst possible combinations of wind, waves, and other factors.
So it's like they're running simulations to see if their solar city can weather a hurricane?
Exactly.
Yeah.
And because these systems are generally unmanned, especially during storms, they need to be designed with a high level of safety in mind.
Yeah, so you can't just send someone out there to batten down the hatches
No.
when a storm rolls in.
Right.
It all has to be able to handle things on its own.
Right, exactly. That's why the document, it talks about consequence categories. FPV systems, are usually categorized as category 1, meaning that a failure is unlikely to result in loss of life, but it could still have like significant economic and environmental consequences.
So there's a lot at stake even if there aren't, like, people out there on the platform?
Definitely.
Makes sense. Okay, we talked about wind, but what about waves? I mean, they can be pretty powerful,
For sure.
especially on the open ocean.
You're absolutely right. And the type of ways they need to consider depends on whether, the FPV system is in a lake
Okay.
or the ocean.
Right.
In lakes, it's mostly about wind, sea,
Mhm.
which are waves generated by like local winds.
Okay.
But in the ocean, you also have to factor in swell,
Yeah.
Those long rolling waves that travel from far off storms. Those can be much more powerful.
So location plays a big role in the design process.
Definitely.
I imagine the depth of the water matters too, right?
It does, yeah. Especially when you're talking about shallow water, you have to worry about the system, like grounding out if the water level drops or being battered by waves breaking on the shore.
Right.
And then there's something called scour, which is where the movement of the water can like erode the seabed around the anchors, potentially destabilizing the whole structure.
Wow, I never would have thought about that. So the engineers have to think about what's happening below the surface too.
Oh, yeah.
Not just what's going on above it.
It's a complex interplay of factors.
It sounds like it.
They even have to consider things like water currents, which can put stress on the mooring system,
Right.
and ice formation in colder climates.
Okay, so we've got these solar panels battling wind, waves, currents, potentially even ice.
It's a lot.
What about things like, bird droppings?
Oh, yeah.
Does that affect the panels?
It does, yeah. It's
I don't
actually one of the things they specifically call out in the document.
know.
Yeah, it's called fouling, and it can include anything that accumulates on the surface of the panels
Okay.
and reduces their efficiency. So that's from bird droppings to algae growth.
I always thought those birds just had terrible aim, but I guess they're actually a design consideration for floating solar farms.
It's true. They have to think about all these factors to make sure, the panels stay clean and operating at peak efficiency.
So we've established that the environment these FPV systems operate in is, well, pretty brutal.
Not easy out there.
How on earth do they make these things durable enough to handle it all?
That's where things get really interesting. They use a combination of durable materials, clever design, and rigorous testing to make sure these systems can withstand the elements for years to come.
Okay.
And one of the most crucial components is the float itself.
Right, the unsung hero holding the whole thing up. So what can you tell us about these floats?
Well, there are different types, each with its own pros and cons. You have single-body floats, which are basically one big platform, and then you have multi-body floats, which are made up of several interconnected units.
Okay.
And the material they're made from is super important, too.
I can imagine. What are some of the key properties they look for in a float material?
Durability is a big one, obviously. They need to be able to withstand years of exposure to sunlight, wind, and waves without, degrading.
Uh-huh.
Buoyancy is another key factor.
Okay.
You need a material that's light enough to float, but strong enough to support the weight of the solar panels and other equipment.
And I'm guessing they don't want the floats themselves to be an environmental hazard?
Exactly, yeah.
Hmm.
The material needs to be non-toxic so it doesn't leach harmful substances into the water.
Right.
You might have heard about the growing problem of microplastics in our oceans.
Yeah.
Well, these floating solar farms, they have to be designed so they don't contribute to that problem.
Yeah, for sure.
And they also want materials that are recyclable so that when the system reaches the end of its life, the floats can be reused or disposed of responsibly.
So they're really thinking about the entire life cycle of these systems.
Absolutely.
From cradle to grave.
Cradle to grave. And to make sure those materials can handle the harsh conditions, they put them through some pretty intense testing.
Oh, I bet.
Yeah. They have these accelerated UV and thermal degradation tests where they basically blast the floats with intense UV light and heat
Whoa.
to simulate years of exposure in a short amount of time.
Wow, talk about a trial by fire.
Right. But I bet that gives them a lot of confidence that these floats can handle whatever Mother Nature throws at them.
It really does. But UV and heat aren't the only things they have to worry about, right?
Right.
Corrosion is another big challenge, especially in saltwater environments.
Oh, definitely. Saltwater is notoriously corrosive.
I can just imagine those metal parts rusting away if they aren't properly protected.
Exactly. So they use special protective finishes to prevent corrosion. And the type of finish they use, it depends on how harsh the environment is.
Okay.
Like, for example, a system in a calm freshwater lake wouldn't need the same level of protection as a system in a turbulent saltwater ocean.
So it's all about matching the design to the specific conditions of the site.
Absolutely.
But we've talked a lot about the floats themselves. What about how they keep these massive platforms from drifting away?
That's where the mooring system comes in.
Right.
And it's a whole other layer of complexity.
Oh, I bet.
There are a variety of different mooring systems.
Okay.
But they all serve the same purpose, to keep the FPV system securely in place.
I imagine redundancy is a key factor here, right? I mean, you don't want the whole thing floating away if one line snaps.
You're exactly right, yeah. Redundancy is crucial. It means having multiple mooring lines and anchors.
Okay.
So if one fails, the others can pick up the slack.
Gotcha. Multiple lines and anchors. But what are those lines actually made of? And what kind of considerations go into choosing the right material?
Well, traditionally, steel wire has been the go-to material for mooring lines.
Okay.
It's strong, durable, and relatively inexpensive. But steel can be heavy, and it's prone to corrosion, especially in saltwater.
Right.
So increasingly, we're seeing the use of fiber ropes.
Fiber ropes, like the kind they use for climbing.
Kind of, yeah, similar, but these are specialized high-strength ropes made from materials like HMPE, aramid, or polyester.
Okay.
They're much lighter than steel, which can be a huge advantage when you're talking about the massive scale of some of these FPV systems.
Makes sense.
And some of these fibers are actually stronger than steel, pound for pound.
Wow, really? That's impressive. But are there any downsides to using fiber ropes?
Well, there are a few things to consider.
Okay.
One is something called creep.
Oh, creep.
Yeah, it's the tendency of the rope to, elongate over time under constant tension.
Okay.
Imagine a rubber band stretching out if you leave it under tension for a long time, kind of like that.
Gotcha. Okay. So creep is something they have to account for when designing these mooring systems.
Oh, yeah.
Otherwise, the lines could become too slack and, compromise the stability of the whole platform.
Exactly. And there are other factors to consider too,
Right.
like abrasion resistance and biofouling.
Mm-hmm.
But overall, fiber ropes are becoming increasingly popular for FPV mooring systems
Yeah.
because of their strength, lightweight, and resistance to corrosion.
So it sounds like designing these mooring systems is a pretty intricate balancing act.
Oh, for sure.
They have to consider the strength and durability of the materials,
Yeah.
the forces of the wind and waves, the depth of the water, and even things like creep and biofouling.
You got it.
It's amazing how much thought and engineering goes into these floating solar farms. But I'm also curious about the environmental impact, I mean, they're essentially creating these like giant artificial islands out on the water.
Yeah,
What kind of effect does that have on the surrounding ecosystem?
that's a great question.
Okay.
And one that's taken very seriously in the development of these systems.
Okay.
The DNV document actually dedicates a whole section to environmental impact assessment.
So they don't just plop these things down in the water and hope for the best.
No.
They actually study the potential impact before they even start building.
Absolutely, yeah. They have to consider a wide range of factors,
Okay.
from the impact on flora and fauna to water quality and even noise pollution.
Okay, let's dive into that a bit more.
Sure.
What are some of the specific environmental concerns they look at? For example, what about the fish and other creatures that live in the water? Do these platforms, disrupt their habitat?
That's one of the key things they look at, yeah. They have to study the potential impact on the local fish populations, making sure the construction and presence of the platform don't disrupt their migration patterns or breeding grounds.
Yeah.
And they also have to think about the benthic communities, the organisms that live on the seabed. They need to make sure the anchoring system doesn't damage those habitats.
So it's not just about the fish swimming around, but also the creatures living on the bottom.
Exactly.
And what about birds? I can see those platforms being, attractive nesting sites, but I can also imagine birds colliding with the panels.
Yeah, you're right. That's another consideration. They actually have to implement bird deterrent techniques
Okay.
to discourage nesting on the platforms, because bird droppings, as we discussed earlier,
Right.
can affect the efficiency of the panels.
Yeah, they can.
And they also have to take steps to minimize the risk of bird collisions,
Okay.
such as using special coatings on the panels to make them more visible.
So they're taking steps to protect the birds, both from the platforms themselves and from, shall we say, becoming overzealous contributors to the fouling problem.
Exactly.
What about the water itself? Does the presence of these platforms affect water quality?
That's another big one. Yep. They have to make sure the materials used in the construction of the platform don't leach any harmful substances into the water.
Right.
And they have to monitor the water quality regularly to make sure there are no negative impacts from the platform's operation.
So they're not just building these things and walking away. They're actively monitoring them to make sure they're not having a detrimental effect on the environment.
Right. It's about finding that balance between harnessing renewable energy and protecting the natural world.
That's reassuring.
And it's an ongoing process.
Well, I have to say, I'm really impressed with how much thought and consideration goes into the design and construction of these FPV systems.
It's a lot.
But I'm wondering, what happens when they reach the end of their life? We can't just leave these massive platforms sitting out in the water forever, can we?
Of course not. That's where decommissioning comes in.
Okay.
And it's actually something they have to plan for right from the beginning.
So it's like having an exit strategy for your solar city.
Exactly.
What are some of the key considerations when it comes to decommissioning an FPV system?
Well, first and foremost, they have to minimize any environmental disturbance during the removal process.
Right.
They don't want to create a bunch of sediment plumes that could harm marine life, and they have to make sure they don't damage the seabed while removing the anchors.
It's like carefully dismantling your solar city brick by brick, making sure you leave the environment as pristine as you found it.
That's a great way to put it. And they also have to consider the impact on other activities in the area, like navigation and commercial fishing.
Okay.
They need to make sure the decommissioning process doesn't interfere with those activities.
So decommissioning is a whole other set of challenges in itself.
It is.
But it's great to know they're thinking about it from the very beginning.
Absolutely. Yeah. It's all part of creating a truly sustainable energy solution.
This is all fascinating stuff. We've covered a lot of ground already, from the material science of the floats to the environmental impact of the entire system.
It's a lot to take in.
But before we move on, I want to hear from you, dear listener.
Oh, good idea.
What's been the most surprising thing you've learned so far about floating solar farms?
Yeah. What's piqued your curiosity?
Take a moment to think about it, and we'll be right back to continue our exploration of this amazing technology.
Sounds good.